laser Doppler blood flow meter. Here we know that blood flow is one of the most important physiological parameters, and it is also one of the most difficult one of the most difficult phenomenon to measure accurately. Why it is difficult to measure accurately? Because the instruments for measuring the flow through the blood vessels within the body have to meet certain specifications. Also, the stability requirements of measuring instruments depend upon magnitude of flow and location and the diameter of the individual vessels. As we all know, the magnitude of flow is not constant. It vary over a wide range. Also, that diameter of the blood vessels vary over a wide range from few millimeters to few centimeters. So, for measuring the flow of blood, besides meeting the technical requirements, measuring system must meet the specific clinical requirements also. First of all, we can discuss about this point that why the measurement of blood flow is necessary. What is the purpose behind the measurement of blood flow? It is necessary to determine the amount of blood delivered to a given region per unit time, because we know that the blood circulation is essential, and since it supplies the body's vital organs with enough oxygen and nutrients needed to operate, and poor blood circulation can potentially harm the heart or kidneys or brain, and it may have fatal consequences also if left untreated. So it becomes very necessary to measure the flow of blood in various parts of the body, so that the fatal consequences can be treated and diagnosed at time. So basically, we are going to deal here with a laser Doppler type of blood flow meter. Most commonly used blood flow meters in our market is we can say electromagnetic blood flow meter, ultrasonic blood flow meter. Electromagnetic blood flow meter, I think it has been discussed in the previous presentations also, and ultrasonic blood flow meter, laser Doppler blood flow meter. So we are basically dealing with we will be dealing with laser Doppler blood flow meter here. So moving on to this blood flow meter, it is a type of blood flow meter that utilizes Doppler shift of monochromatic laser light to measure blood flow. It was first described by Watkins and Holloway in 1978. Now, if we'll see a working Doppler flow meter, here we can see a working laser Doppler blood flow meter. Here the blood is flowing through blood vessels. Laser beam is directed to target, and some reflection takes place. This initiates the measurement process only. Principle of laser Doppler blood flow meter here is based on just the Doppler effect. So what is the Doppler effect? And Doppler effect is the observation that moving objects emit light at different frequency than stationary objects. We all know that every object emits light, and Doppler effect says that moving objects emit light at different frequencies. If the object is moving away from you, the frequency will be lower, and the object is moving towards you, then the frequency will be higher. So, principle of this laser Doppler blood flow meter is that it works on the principle of heterodyning of the optical signals reflected from the non-moving tissue and moving red blood cells, providing the real-time blood flow measurement. So, this is the picture which is representing the principle of laser Doppler blood flow meter. Here, some laser source is emitting light, and it is getting reflected back. So, some stationary part is there in our skin, and blood flow moves inside the stationary tissue or stationary skin, and based on the reflections various reflections, some waves are reflected from the stationary part, and some waves are reflected from the moving part, and after the analysis of this, the desired measurement is done. Basically, this is the principle of working of laser Doppler blood flow meter. So now, if we see that how a laser Doppler blood flow meter works, when a laser beam is directed towards the tissue under study, absorption and scattering takes place. Radiation is scattered in movable structures such as red blood cells, and it is shifted in frequency due to the Doppler effect, while radiation is scattered in non-moving soft tissue is unshifted in frequency. So radiation is scattered in moving cells, and radiation remains unscattered in unshifted in the non-moving cells. A part of the total scattered radiation is brought to fall on the surface of a photodetector, and there the optical heterodyning takes place. And the heterodyne signal is proportional to the Doppler shift frequency, which is amplified, and both the RMS and DC values are calculated. So the RMS values then it is weighted against the back scattered light intensity using the measured DC value as an index of total received power. This gives the output flow velocity. So if you will see the working of laser Doppler blood flow meter, I will not prefer to read this whole paragraph. Rather, I will go with the block diagram only. So is it okay to go with the block diagram? Anyone?
No, continue.
So let me continue with block diagram only. The working of laser Doppler blood flow meter with this block diagram. So in this block diagram, a helium neon laser here is used. It operates at 632.8 nanometer wavelength using a converging lens. This is a convex lens, we can say. It works to give an increased power density at screen surface. A helium neon laser output here is operating at this certain wavelength using a lens, and a receiving fiber is coupled to the photodiode. Here the photodiode, and it is coupled with the receiving fiber, and the role of the optimal part, this is the optimal part, the role ends here. Now the rest manipulations are done by electric part only. The photodetector, what the photodiode do is it just converts the light coming on it into the electrical signal. So the photodetector is converting the signal through it into electric current, and the current that current is proportional to the intensity of incident light. And then the photodiode is connected to a configuration so that it gives a wideband application, wideband performance, okay, basically. So finally, the output is obtained by taking the RMS value of the total signal. Here RMS value is taken, and total, this is output is coming in this digital readout. So before RMS conversion, this setup is present for receiving audio output of the signal to hear the flow pattern. Here it is taking this scheme is taking the signal, and this buffer just we know that it passed the same signal in our desired form. So it is passing in here audio output. We can take also that how is the movement of blood here, and we can hear the sound of that. So this is the working principle of a laser Doppler blood flow meter. Now I think we should move. In this, we can see that this is a conventional laser Doppler blood flow meter. And here, the target is fixed with this conventional laser Doppler blood flow meter. And if you see the block diagram, as discussed earlier, the optical part is the green part, and the orange part is the optical part, and green part is the electronic part. The laser diode here emits laser beam that passes through lens and gets reflected back to photodiode from the target, and later the electronic part performs the rest manipulations to produce the desired output. So this is the block diagram as we discussed here. Now, what are the advantages and disadvantages of laser Doppler blood flow meter? If you see the advantages, it is a non-invasive technique. Non-invasive, we can say it is a non-surgical technique. We can just put the sensor on our skin, and we can measure the flow of blood. It also have real-time measurement capabilities, and it offers light reproducibility and sensitivity. Various disadvantages of this flow meter includes poor selectivity, baseline instability, and restriction in site of measurement. Also, other applications, if we'll see the applications of laser Doppler blood flow meter, it includes cardiac blood flow, retinal blood flow measurement, skin blood flow measurement, and other applications include blood flow through the free flaps, pedicle flaps, wound healing, gastroenterology, Also, the blood flow monitoring in peripheral vascular disorders. Its application is also in cerebral perfusion monitoring in models of stroke and brain injury. Tumor perfusion monitoring is also done, and it is also used for monitoring of angiogenesis. Angiogenesis is the process of formation of new blood vessels. And if you see from the intensity, the concentration of blood in different regions can also be detected by using this laser Doppler blood flow meter. So this can also be used for flow map generation also from by the use of flowmetry. Now, if we see that if we see the technological advancements in laser Doppler blood flow meter in recent days, apart from conventional laser blood flow meter, technologically advanced models have also arrived. A laser diode, photodiode, and optical wave card, these all are arranged and working on the same principle. It has been made compact, and such a small portable laser blood flow meters have come into picture. That may be amazing to see. Sensor is attached comfortably at the target, and then the measurement begins. Wireless communication technology, as we all know, that it also has been developed to a great level nowadays. So this wireless communication technology can be used for transmitting or displaying or recording the measurement data. So it can be ideal, and not only for the various measurements, but here we can see that the lower graph is showing the conventional laser blood flow measurement, and upper one is showing the measurement by this small new blood flow meter, laser Doppler blood flow meter. So it is not ideal for only bedside monitoring, but it is also useful in personal healthcare management or in the field of sports medicine. So these are the various technological advancements we can observe in the field of this blood flowmetry. So I think that's all for this presentation. Thank you. Thank you all.
Anybody have any question? Why this name is Doppler?
Because it is using Doppler effect. Doppler effect, you all know, as I explained, every object is emitting light. And yeah, I turned off my sharing.
No, sharing is on, but your current slide is not shown.
This is the Doppler effect. It is based on basically the Doppler effect. So it has been named laser Doppler blood flow meter. As some laser works here, laser emits.
Showing your slide. I think you have to reshare.
Okay, 1 minute. So this is named laser Doppler blood flow meter because it works on the principle of Doppler effect. Doppler effect, we all know that every object moving at speeds emit different radiations of different frequencies.
But your
So
screen is black. Slide number 4.
yeah, it may come. It may take time. 1 minute.
Yeah, now visible.
This device generally works as a laser is there in this device. A laser working on 632.8 nanometer wavelength. It emits some beam of radiations, and this beam of radiations strikes with the skin where we keep the sensor of this laser Doppler blood flow meter. This beam of light strikes with the surface, with the target, and gets reflected back.
Your device is basically measure the speed of the blood flow. What?
Yeah, speed of the blood flow, whether every part of the body is getting sufficient blood supply or not. Because if poor blood circulation happen, it can potentially harm our bodies or various parts of the bodies.
Name of this device?
Laser Doppler blood flow meter. Some laser used works on the Doppler effect, and it is the
laser is not useful. I think it has side effect.
Yeah, it has side effect, but it has side effects if it will be used at higher frequencies. It is clinically tested that at what frequency it is not it has not traumatic effect. It should be least traumatic actually. it is tested before operation that it should be least traumatic.
Okay. Okay, your PPT is very nice. Thank,
You,
thank you. Thank you.
thank you.